This is a session, an intro session for Envoy, but I'm gonna specialize it for Envoy at Lyft and how we use it in production. Envoy came out of the networking team at Lyft, starting in 2015. Development started, and it was open sourced in late 2016. So I am Jose Nino, and I am a software engineer in the networking team at Lyft. But I'm also an Envoy maintainer, so I'm in a interesting middle ground where I help create and maintain features in Envoy, but I also need to make sure that I can operate and roll them out to Lyft as a whole. So to begin, I want to go a little bit about my time at Lyft. I actually started at Lyft about a month before we open sourced Envoy. And my first task when I got there was to read through all the documentation and make sure that it made any sense to a newcomer. After that, we open sourced Envoy, and I started working on a cluster at Lyft we call Envoy Outbound, which is a cluster of proxies that communicate with external partners over stable IPs. That was something that was heterogeneous at Lyft before, and so every developer was really building out their unique solutions for that. So we wanted to provide something that people could just plug and play. After that, I open sourced a service and a couple libraries in Golang. And in addition to the production code, I also wrote the vast majority of the open source documentation for those libraries. Then after that, I worked expanding Envoy's outlier detection system to include success rate-based outlier detection to help developers at Lyft really understand what was going on in their clusters. And then over the last couple of quarters, I've been working on the XDS APIs for Envoy, which allow us to dynamically configure the proxy, the data plane via the control plane. So I've been rethinking a lot about how we do configuration management at Lyft. So the reason I tell you this story is not just because I like talking about myself, but because really there is a theme here, and the theme is about developer productivity. The story that I want to tell today is that we know that Envoy is a powerful and complex tool, but it's really the networking team's focus and responsibility to hide that complexity from our product engineers at Lyft to enable them to write product code that does what Lyft does. So why is this important? Well, it's important because I believe that as infrastructure engineers, our main role is to build compelling products for our product engineers and enable them to write product code. It's also because Lyft is growing very fast. So we're going from about 500 engineers to over 1,000 engineers by the end of the year. So that's a lot more hands in our code base. And it's important to allow complexity to really move away and allow people to do their day jobs. And also, the number of services at Lyft is growing. So we're going from a couple hundred services to maybe double that. And so the complexity of our distributed system is really increasing. So a brief overview of where Envoy is deployed at Lyft, and the summary really is everywhere. We have front cluster that we call front Envoy, and it handles all the public edge out from the clients, and it routes into our service mesh. So here in our service mesh, we have a polyglot deployment where every single service sits down on the host with a sidecar Envoy. And so regardless of if the service is written in Python or Go or our PHP monolith, it all communicates via its sidecar Envoy. It also makes requests out to external partners from the mesh and also via the Envoy outbound cluster that I was talking about. And then the networking team also owns a couple ancillary services to the Envoy ecosystem at Lyft. So we have tracing collectors for our tracing data. We have a rate limiting service. That's what I open sourced last year. And we also have a service discovery service. Kind of confusing turn of words there, but it just does service registration and service discovery. So the frame of reference I want to talk about here and hiding this complexity from that topology is really configuration management. Configuration management for proxies is complicated, and really Envoy is no exception to this. Operating the proxy itself, the data plane, should be reserved for a select few, the networking team at Lyft, for example. But really, our end users should be able to configure the proxy via the control plane to go out and do what they need to do. So historically, when Envoy started at Lyft, we really only had static files where a human, whether it be someone in the networking team or a service developer, would go in and edit a giant JSON file of thousands of lines to add a new public route or add a new service route. Then we would deploy those static files out to either the front proxy or the service mesh via deploy magic, and then that deployment would be that configuration would be enacted in the proxy. Then, as Lyft started to go into this service-oriented architecture, we needed to provide less surface area for service developers to go in and manipulate the Envoy configuration. So we created a bespoke templating system of configuration where the surface area for service developers was smaller, but still we had to combine that into this giant JSON file and deploy it out to the mesh or the front proxy. Again, here the configuration files were being deployed in tandem with binary deploys of Envoy. So let's frame this in a use case. So I'm a service developer. I'm creating a new service at Lyft, and I want some internet traffic to get into my service. In this previous system, what I would do is go into this giant JSON files I'm talking about, add a new route, then ask someone in the networking team to approve my route, and then have the networking team deploy that configuration out with binary deployment. So this is really the opposite of what I'm talking about of developer productivity, because the complexity is really in plain sight. The configuration deployments are being deployed out with binary deployments, so this is risky. We're sending out production proxy code out with the same configuration code, confounding variables into perhaps an incident. The user experience is really tedious and fragmented. So service developers are changing configuration files, but then that configuration is being deployed out by the networking team. So really there's no streamlined ownership of these changes. So that is where, in the middle of last year, come the XDS APIs. XDS stands for a host of APIs that we have defined in Envoy for dynamic configuration. So route discovery service, cluster discovery service, listener discovery service, where you can discover all these artifacts dynamically and without requiring a binary restart. The APIs are gRPC based, so if you were in the previous session, you have the context from that. They are enabled for bidirectional streaming, and this really allows us to separate configuring the control plane from the data plane operation. And on top of that, then we are able to build really neat systems that provide us solutions for the problems that I've been describing. So this is what we've built at Lyft, and I want to go on sections by sections explaining what we've done. So on the left-hand side, you have what the end user interacts with when they're interacting with the configuration. So up at the top, you might think of the configuration for the front proxy. Perhaps you want to add a new route with a given path and pointing to a specific service in our service mesh. And you might also want to configure the service mesh. So at Lyft, every single service has a file that we call the manifest. And this manifest not only configures proxy configuration, but you can imagine a segment that configures proxy configuration to look something like this, where you might define internal services at Lyft. So we might have roads or job scheduler as our scheduling system. you might imagine some external hosts. So if you want to communicate out to AWS Kinesis or SQS or S3, and you might also want to allow your service developers to specify different settings like circuit breakers to protect against DOSing their own service. So after an end user changes their configuration, the configuration is deployed out to a cloud storage, be it AWS S3 or a GCP solution. It doesn't matter. At Lyft, we use AWS S3. And then on the right-hand side sits Envoy Manager. And Envoy Manager is a Go service that implements the XDS APIs I was describing. So Envoy Manager is a service that comes in 3 parts. The first part is a data processing part. So we're using those files that service developers can edit, and we're generating Envoy config artifacts via the XDS API. So from that path definition that I showed before, you generate a route configuration via the RDS API, and then in tandem, a cluster configuration via the CDS API. The second part of the service is caching. So after you've generated these artifacts, you cache them, and then on the end is the XDS server that actually speaks the XDS APIs out to the proxies that it's configuring. And then in the last step, you see how Envoy Manager delivers this configuration artifacts via the XDS APIs out to, say, the front proxy or the service mesh. So that's, again, the whole flow of the new configuration management we've been designing and implementing at Lyft. So this is how it fits in the initial diagram that I showed. Envoy Manager is just another ancillary service that we run at Lyft, and it lives in this Envoy ecosystem to provide configuration artifacts to the entirety of the proxies deployed at Lyft. So how does this new configuration system is actually hiding this complexity and enabling developer productivity? So let's go back to the use case that I described at the beginning, where a service developer wants to expose their service to a new public-facing route. The service developer will first start by reading our documentation. We believe that documentation is actually really important to enable developers to do what they're seeking to do, and actually to scale entire engineering organizations. It's really not scalable for me to answer on Slack every time someone has a question, but if I can send a link out to a very detailed explanation, we can scale our engineering org to thousands of engineers in a less time-consuming manner. So we have documentation on top of the open source documentation that Envoy comes with. We also have clear step-by-step guides. So as I said, it's easier for me to send out a doc and say, please follow these instructions. We also have FAQs, and we've even dabbled into video tutorials to allow our developers to see how this process works. Then, after a service developer has read our documentation, they can go and make the change that they want into the configuration. And configuration changes at Lyft are done the same way that production code is changed. We have PRs, and PRs can be reviewed and approved, and the pull requests are also integrated into our continuous integration. So before we allow a service developer to affect production changes, it runs in continuous integration. After the change is made and merged, we use a text-based chat deployment strategy. So service developer can deploy their configuration changes just like they would deploy their own service changes. They ask for the deployment, and then the chat-based UI tells them what is going out in the payload, and they can start Jenkins job to deploy that configuration change. So really, there's no fragmented UX in terms of making service changes and making configuration changes. After the deployment has started, the configuration is deployed out into our service mesh or the front proxy the same way that production code is being pushed out in several stages, and Canary and is included as part of the same deployment pipeline. Versioning is a given with configuration. We leverage Git as our versioning system for both production code and also configuration code. This is important because we have semantic SHAs attached to configuration changes. Service developers can see that SHA flowing through the entire pipeline, both from the beginning when they make the change and commit it to master, all the way out to the version that is being given out by the envoys. And this SHA is also used in monitoring tools. So service developers can see how this configuration change is flowing from the time they deploy out to Envoy Manager, generating their configuration artifacts and flowing out into the proxy. And lastly, as a service developer is deploying configuration changes, we provide the same monitoring tools that they're accustomed to in their service deployments for configuration changes. So for example, here we have a Grafana dashboard for Envoy Manager, where when new configuration changes are being deployed, you can see the version shifting from the old version to the new version, and you can see as any problems arise in the deployment. For the example that I was giving of a new public route, you might also want to go to the front Envoy dashboard and see if that new route actually doesn't have a backing cluster, for example. And so we see 500s, or if the route is actually not deployed and a client is actually using the new route, you can see an increase of 400s, for example. And lastly, you can also, at Lyft, we give default dashboards for every single service in the mesh. So if you're a service developer and you're pushing out a new route, you can finally see how that traffic is now flowing into your service. So the wins here are clear. We allow service developers to configure the proxies separate from Envoy changes. This not only means that they own the change from end to end, it also means that configuration changes do not mean binary changes for Envoy. It also means that the service developers own the deployment of those changes, and that is separate from more delicate and a slower process of Envoy changes going into production. It also opens up the future for more friendly user interfaces for service developers. So as I explained, we still have big files on the left, but you might imagine, for example, in partnership with a new company called Turbine Labs, where a service developer won't need to go into a big JSON blob, but can actually go into a nice web UI and create a new route just by following a form. So the message that I want to leave you with is that, yes, the networking team at Lyft created and maintains Envoy, but it's really our focus and our responsibility to develop easy-to-use and accessible abstractions so that service owners can configure, deploy, and debug Envoy at scale. So that's it for me. And now we have some time for questions. So do you mean of the Envoy code base?
Yeah, so like it's the contributor
Mhm.
contributes a new feature, how do you make sure that it doesn't break for everyone else?
Yep. So we actually, at Lyft, we have a private repo called Envoy Private, and that has a submodule for upstream Envoy, and we pick up upstream Envoy twice a week and deploy it out to our machines. We use the same deployment pipeline that you saw for configuration changes for Envoy changes. So we upstream Envoy, and then we deploy it twice a week on scheduled trains. That's only for the networking team. So the networking team is it fully owns deploying new versions of Envoy, both to our front proxy and to the entire mesh.
Yeah, so I often hear about Istio, which also does some sort of like configuration, like on top of like Envoy. What do you think is the relationship between Envoy and Istio?
So Istio is built on top of Envoy. So Istio provides a whole control plane solution, right? Envoy is just the data plane, and Istio is really building a complex and rich set of solutions on top of that.
Right. So like, is there any like, what's the reasoning like to use or not use Istio? For example, in your example in Lyft, I think you guys are not using Istio. Like you have your file-based configuration. Yeah. What's the reason? And what do you think is the value that Istio provides?
So I can speak a little bit about Lyft. As I said, Envoy started at Lyft, so we have the entire history of Envoy to deal with, right? So we started with a very small configuration system, and we had to iteratively build that to provide value for Lyft. I think it's hard to say, could we use Istio, could we not use Istio, because we have a lot of baggage that doesn't go out for free. I think to provide more context into Istio, I think there's better people out here in the conference for that. So I think you can go and chat with them. Yep.
Do you have any data on the prevention network impact?
You mean of like the Envoy topology at Lyft?
Yeah,
Or like do you mean like adding Envoy to each hop of your mesh?
well, actually both. I mean, if you have any feeling or any data on that.
Do you have a?
We generally don't provide data. Hi, we generally don't share data on that, just because it's very dependent on what features you're actually using. So it's like, are you using tracing and logging and all those types of things? I would say in normal deployments, the numbers that we generally give people it's typically like 1 millisecond or less per hop overhead. So you can kind of do the math depending on how many hops you generally have. But again, what we encourage people to do is go do your own performance benchmarking with the features that you plan on using, because it's just dependent on what features you use.
And then I think we had over here. Yep.
So I think it's very interesting what you're doing with configuration for Envoy. I'm actually looking into doing something similar. So I would ask if you have any plan to open source Envoy Manager.
Right. This. Let me bring back a slide that shows Envoy Manager. So like I said, Envoy Manager is a service that kind of comes in three. And I believe that almost every single configuration management service that you might deploy at a company actually would look similar to this. The challenging part about this is that the data processing part is very company specific, right? It really depends on how you're doing things at your company. However, the caching and the XDS server part, you might imagine, is very company agnostic. And the Envoy project actually has open source a project called Go Control Plane, and it's parallel in Java Control Plane, which implement the caching and the XDS server part, so as libraries. So you can when you're in your company, you can create a new project and import those libraries and add the data processing part on top of that. At Lyft, we're actually, so again, like I said, because we created and run Envoy and we've run with the entire history, we have a lot of baggage. So this actually started in parallel with the Go Control Plane project. And currently, we're looking into replacing the caching and the XDS server part with Go Control Plane so that we can become a part of that community. And it's also, it's a benefit to the community as a whole to kind of converge in one accepted standard for the parts that we can converge on. So the short answer is no, we're not planning on open source Envoy Manager, but there are open source parts of it.
Okay, thanks.
Mm-hmm. Yep.
So, do the application deployment model that you guys use at Lyft, does it leverage any unique Envoy capabilities that are generally not available in other reverse proxy solutions?
If I understand the question correctly, is Envoy providing features that other reverse proxies don't provide? Is that the question?
What kind
or
of those features your application deployment model in your company rely on?
I don't think I understand. Let's take that question offline so we can chat about it.
So Envoy has some plugins for logging metrics that you showed. How extensible is that plugin model? Could you speak to that a bit?
Yeah, and actually Matt just did a lot of work in reorganizing Envoy as the Envoy project so that we have a more clear definition between what is the core proxy and what are the extensions. So like you said, there are extensions for tracing and for stats outputs and for logging. Also, we have a very rich layer 3 and 4 and layer 7 filters. So really, Envoy is really extensible, and it's up for the community to open up issues and propose new ideas. I think we really look for rich community involvement, and if you have new ideas that you're interested in discussing, we can chat about it.
How Envoy addresses the single point of fail use if there are any load balancers or things like that?
Sorry, can you repeat that?
Single point of fail use.
Okay, how it
handles.
So how does Envoy handle single point of failures, or is Envoy a single point of failure?
Yeah, exactly.
I mean, it's hard to say. You mean like what happens if we deploy a bad Envoy binary, and then so I mean that happens, right? And that's why we have. I think it happens in two parts, right? We have. That's why we have deployment stages, so we can roll out to staging and verify that nothing is on fire. Then we can roll out to Canary, then roll out to production, and actually roll out in stages within production. So that's one side of that. I think the other side is that we have a very high standard for testing in the Envoy code base. So we have a big surface area covered by unit tests, and actually one of the maintainers is working really heavily right now in integrating fuzzing into Envoy. So I think there's a lot of ways to prevent that kind of stuff happening.
So how are you dealing with conflicting changes in configuration? Because it seemed to me as if multiple developers in principle can run into that problem. And I mean, one thing is to deal with it technically, that you figure out that it's incompatible, but also on an organizational level. So I mean, you have staging. Maybe staging is not 100% identical to production and things like that.
Mm-hmm. That's a very good question. So I think, starting at the source, it's really valuable that we have Git as a versioning system for both for production code and also configuration, right? So at least that way there's some sort of vetting process of what changes are happening. We can code review configuration changes just like we code review production code. We also have, like I showed, continuous integration on configuration changes. So we can think of scenarios like, you know, are these two routes pointing, you know, shadowing each other or erasing each other? That's an area that we are actually looking to invest more in to integrate into continuous integration tests like that to catch things before they get deployed out. I think that's it, and it's all close to the time that we have. So thank you very much. I'm going to be out in the halls. Matt is going to be out in the halls, and come to us with any questions you have. Thank you.